Today's topic of additive manufacturing, or 3D printing as many call it, isn't the first time Mouser has touched this topic with our Empowering Innovation Together program. Back in 2016, we'd partnered with IEEE and Made in Space to see what could be printed with the new Made in Space 3D printer recently installed on the International Space Station. As part of my research for that program, I went out and purchased one of the new desktop 3D printers and started printing random things while being mesmerized by the print head building layer upon layer of extruded filament. Admittedly, productivity dropped for a while. Not long after, I discovered the world of 3D printed Warhammer 40K figures that were available. And being a player since 3rd edition, I was never quite happy with the quality of the early models, but it helped open my eyes to the possibility of 3D printing at scale. So to help us understand how far additive manufacturing has come and the potential it has moving forward, I'm excited to have as our guest today, Mark Beatty, founder and CEO of 3D Agility. Mark, welcome to the Tech Between Us. Tell us a little bit about yourself and what 3D Agility does.
Sure, Raymond. Thanks for having me. I'm thrilled to be here. My name is Mark Beatty. I've been in tech and manufacturing for about 20 years now. And after multiple roles in commercial functions, sales, product management, strategy, continuous improvement, I decided to take a leap and start 3D Agility about 3 years ago. And what 3D Agility is really focused on is helping companies take transformational leaps. There's a lot of change happening right now, not just with technology, but with politics, with talent. And sometimes companies are interested in these technologies or creating change, but sometimes it's difficult. And that's what 3D Agility really focuses on. We really focus on partnering with companies, identifying their strategies and what they want to be, and then deploying this technology in a thoughtful way.
So specific to additive manufacturing, Mark, I think in the minds of a lot of people, 3D printing is games and toys, and back in the day, one of the biggest jokes was, well, the first thing you print with a 3D printer is your next 3D printer, and we even have one here in the Mouser lab, printing off one-offs for our projects and our prototypes. How are you seeing companies using 3D printing these days? Is it still prototyping, or has it moved beyond that?
You're definitely seeing a massive shift beyond that. I think some of the perception around games and toys and things like that is actually because kids are super curious about this technology. There's no expectation or no risk, right, to go out and try it and discover. So as, rudimentary or silly toys seem, it's really because it's kind of fun and it's an outlet to be creative. So that certainly is some of the perception. On the back end of that, really within the last, I'd say 5 to 7 years, you've seen exponential leaps in the technology itself. The capabilities of the technology and the hardware, a lot of advances in materials, the price points of a lot of this hardware has come down. The reality is 3D printing has been around for decades. The barriers to entry to get into it were very, very high. The learning curve was very steep. And I think that created some barriers to entry there.
So you mentioned a lot of movement in the technology, especially within the last 5 or 7 years. I had no idea it was that recent, some of these advancements. What's driving companies to move into additive manufacturing? Is it simply the technology getting better, or are there other things involved?
It's multiple things. I think if you look at the hardware, if you start at the hardware itself, you're talking about bigger, more powerful lasers. You're talking about the ability of more advanced nozzles and the hardware with inside kind of the build platform itself. So that's one piece of it. There's major leaps in the hardware itself. But you think about just what AI has done. A lot of these platforms now have built-in AI to help the builders and the manufacturers make adjustments as the print is happening real time. So the software is providing more intelligence and, again, reducing that learning curve. Materials are huge. I mean, there's a new material, I feel like, released every month. So that's a good thing.
Right.
And that can also be a challenge, right? So to master kind of the catalog of materials that you have is one step, but then to have the ability to continue to be curious and bring in new materials as they're developed, that can be challenging. So it's across multiple aspects of this ecosystem that is really driving this adoption. I think the other side of it, which was one of the reasons that gave me the inspiration to start 3D Agility, is going into COVID, we knew that some of the supply chain was fractioned. We knew kind of that there was some Band-Aids in place in some areas. I think what COVID did, though, is it really opened those fractures into gaps, right? Gaps and valleys, and, created a lot of historical shift there. So where there might have been customers curious to explore additive, COVID really gave them a new initiative or a renewed interest.
Now, is this more from a supply chain? In other words, being able to manage and retain more of their own supply chain? Because obviously, as you mentioned, COVID destroyed some supply chains globally. Was that one of the driving factors for customers, for companies to look at an additive manufacturer? Or were there other things, things like sustainability?
It could be all of it, or it depends on the customer and how much their supply chain was really exposed globally. I think what they were really trying to do is get creative to really come up with maybe new approaches or new takes on solving some of these problems where, lead times may have been 10 to 12 weeks, and then post-COVID, it could be a year in some cases. And when you have one component holding up kind of an entire build, that puts a lot of tension between the customer and the manufacturer. That puts tension in the system. So I think that was one catalyst to really start driving additive, along with all those other things that we had talked about.
Now, as companies look at moving from traditional manufacturing to additive manufacturing, or even incorporating into select areas of their supply chain, what should they be looking at? What kind of factors would a company need to take into consideration to make that move?
The customer or the manufacturer in this instance really needs to understand their portfolio and ultimately what does that service model look like. The biggest piece of advice that we give to our clients is to really be thoughtful in what you're trying to unlock. And the other big piece of advice is there's very rarely one piece of hardware that will fix all your problems. So if there is a hardware salesperson coming in saying, hey, this is going to make everything better, that typically is a red flag. You really want to understand where that piece of hardware is going to be deployed, where in your product life cycle, what are your expectations from it. And then the biggest thing, Raymond, is to really consider the other levers around it. Do you have the talent internally to run that equipment? Do you understand the post-processing of that equipment and the needs beyond just printing it? Even the fact of just getting through some of these things in a way to really understand that end-to-end is vital. So those are massive decisions. And I would say you almost want to deploy this additive curiosity as like you're building a baseball team. You need some pitchers, you need some 4-slot hitters, you need some really great outfielders. It is not a one-size-fits-all. And that's where some of the conversations have come our way where a client will say, you know what, we've done that before. We've tried it. It doesn't work. It's not for our industry. It's not for our type of product. And then you start asking the questions, well, what type of hardware did you pick? What type of materials were you looking at? What were those processes behind the scenes supporting it? And it's within one or two questions to say, you guys had a great idea. You just didn't pick all the variables to make yourself successful.
And Mark, I know a lot of industries are having issues finding people that are properly trained and have the right education for these new technologies. Is there a considerable learning curve from a people standpoint to move to additive manufacturing? You said, you needed people who understood the front end and the back end. And are you guys seeing a lot of that going on in the industry as companies transition?
Absolutely. And it's something that we as a company are very, very invested in. We've partnered with local universities. We're bringing in interns and co-ops to help them. I think even from the front end of that, Raymond, because the technology is so new, for many universities, it's hard to teach the students what they need to know. So it's this gap of trying to get the kids real world experience, but also then help the universities of building out the right curriculum and right experiences for those kids to learn. Listen, there are brilliant, brilliant engineers out there that can learn these things. The bigger question that most organizations need to ask themselves are Are you going to carve out that engineer, that manufacturing professional, and assign them to this role, give them the resources, the time, and also the patience to master it, right? If you're willing to carve it out, and like I said, there are some brilliant people out there that can certainly master this space, but it's all those other things that you need to take into consideration. You're not going to buy a printer, put it on your manufacturing floor, and
boom,
right, and hit print tomorrow and have the results that you think you want or you need.
I think it's great that you guys, as a company, are bringing up the next generation within the technology. In fact, our summer intern here, she came in and we are teaching her real-world engineering with actual design work. And it's a huge difference between that and what they learn in school. So kudos to you guys.
Yeah, likewise. And that's reality. Coming from this world of connectivity, you cannot go to a university and come out with a degree in connector design. So my previous employer, they worked very, very hard to bridge that gap and give students that experience. The additive space is very similar to that.
It sounds like even though it's called additive manufacturing, there are tendrils of this that reach up into design, whether it be mechanical design or system design. Can you talk a little bit about how additive manufacturing is changing the actual design process rather than just the back-end manufacturing?
Yeah, absolutely. So again, I think that's the curious part of where additive is important to you as a company and to where it will unlock the most value for your design cycle. So traditionally, additive has been really, really focused on prototyping, where engineers can be curious, develop quickly, make changes based on customer feedback or mechanical features, whatever it may be. What is interesting now, though, is that the way that additive is being looked at by some customers, especially like in defense, aerospace, where weight and strength and things like that are super, super important, they're looking at brand new geometries, right? Brand new designs that if you would have taken that part to an injection molder 10 years ago or 20 years ago, they would have said, there is no way that we could make this part. So I think that's the really interesting thing of it's not just kind of filling a gap of quick prototypes anymore. It's now unleashing new design possibilities, which could have a whole nother effect.
And it's interesting, you had mentioned the new materials and whatnot, and it sounds like aerospace and defense. I mean, lots of, for example, titanium and carbon fiber composites and things like that. Are all those in your new portfolio of metals that a company is able to use in additive manufacturing?
Absolutely. So that's the one cool part when you pick the format that you want to print in, whether it's powder or filament or liquid, you do open this whole brand new recipe or menu of materials. And in some cases, they're relatively new materials, also kind of sustainable materials. So if it's important to have like a recycling take or, a bio take, you can immediately go out, get those materials, try them, test them, and understand, hey, will they actually fit our application? For us, we're really, really focused on kind of the plastic side. So parts that come from the world of injection molding or rotational molding or thermoform, that's really our sweet spot. We dabble in metals. Metals can be tricky. When you have a geometry or a shape that you simply can't mill or it'd be too expensive or too complex to mill, that's really where you want to pursue 3D printing for metals. If you're just 3D printing some type of hatch or latch or something like that, it's still hard to hit the economies unless it's something super special. But you're spot on. Space is very, very interested in kind of printing titaniums and high-end metals, same with some defense applications. But that would be kind of the first question is, how complex is your geometry? Let's start there and then understand what technology would be viable.
Sounds like you get a huge portfolio of potential materials, regardless, depending on the different factors involved.
Yeah, exactly. And that's the beauty, right? So you could take something that you're trying to retrofit. So if it's a standard nylon, you can go out and match that exact nylon. So it's apples to apples. We've had conversations with customers. It's like, okay, well, why is this part failing? Or what are some of the concerns about the existing design? And then those are opportunities to maybe incorporate a new material. So it's just this constant cycle of curiosity to not just make the change from traditional manufacturing or fill a gap, but also make it better.
That's a wrap on today's episode. Stay tuned next time as Mark and I discuss additive manufacturing and its impact on replacement and obsolescent parts. Until then, explore more content from Mouser's Empowering Innovation Together series by visiting mouser.com/empowering-innovation.